There's something almost magical about looking up at the night sky. The same stars that guided ancient explorers now spark questions in us about the very fabric of the universe. Thousands of years ago, civilizations without telescopes or satellites mapped the heavens with astonishing precision, weaving stories of gods and cosmic battles into the constellations. Today, we peer through the lens of modern astronomy, uncovering black holes, distant galaxies, and the secrets of dark matter. But what if these two worlds, ancient wisdom and cutting-edge science, aren't as separate as we think? What if the answers to some of our biggest cosmic mysteries have been hidden in plain sight, etched into temple walls and encoded in ancient texts for millennia? This is the story of how humanity's oldest stargazers might have known more about the cosmos than we ever imagined. From the Mayans, who calculated planetary cycles with jaw-dropping accuracy, to the Egyptians, whose pyramids align with celestial events like a grand cosmic clock, these cultures left behind clues that modern astronomers are only beginning to decipher. Even the Vedic scholars of ancient India described the universe in ways that eerily resemble our understanding of quantum physics and multiverse theory. How did they achieve this without the technology we rely on today? Were they simply lucky, or did they possess knowledge that's been lost to time? This video isn't just about revisiting history, it's about rewriting it. We're going to trace the threads that connect ancient sky watchers to today's astrophysicists, revealing how their insights challenge and even complement our modern understanding of the universe. By the end, you'll see the night sky differently, not just as a canvas of stars, but as a bridge across time, linking the curiosity of our ancestors to the discoveries of tomorrow. So let's begin this journey where myth meets science and the past illuminates the future. The cosmos is waiting. The night sky was more than a spectacle to ancient civilizations. It was their roadmap, their calendar, and even their sacred text. Take the Polynesian voyagers who crossed thousands of miles of open ocean with nothing but the stars as their guide. They memorized the rise and fall of constellations, the subtle shifts in brightness that signaled currents, winds, and distant islands. Their star lore wasn't just practical, it was a living science passed down through chants and carvings. Then there's the Babylonian astronomers, who meticulously recorded the movements of Venus on clay tablets over 2,500 years ago. Their observations were so precise that modern researchers can still use their data to track the planet's cycles today. But perhaps the most jaw-dropping artifact is the Denderer Zodiac, a celestial map carved into the ceiling of an Egyptian temple. This intricate bas-relief doesn't just depict constellations, it captures the precession of the equinoxes, a slow wobble in Earth's axis that takes 26,000 years to complete. How could a civilization without telescopes detect such a subtle cosmic dance? The answer might lie in their patience. Generations of priests tracked the stars, noting shifts imperceptible in a single lifetime but undeniable across centuries. Then there's the Antikythera mechanism, a corroded bronze device salvaged from a shipwreck off the coast of Greece. At first glance, it looked like a lump of metal, but X-rays revealed gears and dials of staggering complexity. This 2,000-year-old computer could predict eclipses, track planetary positions, and even account for irregularities in the moon's orbit functions we'd expect from a modern observatory, not a relic from the ancient world. What's truly astonishing is how these artifacts align with today's astronomy. The Denderer Zodiac star positions match ancient sky charts reconstructed by NASA. The Antikythera mechanism's eclipse predictions are accurate to within a few hours. These aren't lucky guesses, they're evidence of methodical, advanced observation. Some researchers speculate that lost technologies or forgotten observational techniques might explain these feats. Others suggest that ancient astronomers simply had something we've lost: time. Without light pollution or the distractions of modern life, they could study the heavens night after night, decade after decade, compiling knowledge we're only now rediscovering. The deeper we dig, the more these ancient star maps challenge our assumptions. Were these civilizations just skilled observers, or did they inherit fragments of even older wisdom? When a Polynesian navigator speaks of star paths, or an Egyptian priest carves a zodiac that accounts for celestial drift, we're not just looking at history, we're glimpsing a conversation across millennia, one that's rewriting our understanding of humanity's cosmic journey. The Great Pyramid of Giza stands as one of humanity's most enduring mysteries, not just for its towering presence, but for the way it seems to whisper secrets of the stars. When you stand at its base and gaze upward, you're not just looking at a tomb or a monument, you're facing a colossal stone compass, aligned with uncanny precision to the cardinal directions. But the real marvel lies in its celestial connections. The pyramid's three main chambers align with the stars of Orion's belt, mirroring their configuration in the night sky. This isn't a vague resemblance. Modern astronomers have confirmed the alignment matches the constellation's position during the pyramid's construction over 4,500 years ago. This cosmic precision isn't unique to Egypt. Half a world away, the temples of Angkor Wat in Cambodia stretch across the landscape like a reflection of the heavens. The entire complex mirrors the Draco constellation, with its central towers representing the dragon's coiled tail. Even more strikingly, the temple's corridors align with the solstices, allowing sunlight to pierce through specific doorways like a celestial spotlight during the longest and shortest days of the year. These aren't artistic choices, they're deliberate, calculated designs, echoing a universal language written in stone and stars. How did ancient builders achieve such astonishing accuracy? Without laser levels or GPS, they relied on something far more profound: patient observation. The Mayans, for instance, used simple tools like crossed sticks to track the sun's path, marking its movements with notches in stone. Over generations, they compiled data so precise their calendar could predict solar eclipses centuries in advance. Similarly, the builders of Stonehenge arranged massive blue stones to frame the summer solstice sunrise, a feat requiring not just engineering skill, but an intimate understanding of the sky's rhythms. Some theories suggest these alignments served practical purposes: calendars for agriculture, markers for seasonal rituals, or even navigational aids. But others propose a more tantalizing idea, that these structures were attempts to communicate with or honor celestial beings. The Dogon people of Mali, for example, have long held knowledge of Sirius B, a star invisible to the naked eye, describing its dense nature centuries before telescopes confirmed its existence. Could such insights have come from advanced, now lost teachings? Modern technology allows us to test these ancient marvels with fresh eyes. Archaeoastronomers use software to simulate skies from millennia ago, revealing alignments too precise to dismiss as chance. When researchers modeled the sunrise over Mexico's Pyramid of Kukulkan during the equinox, they witnessed a shadowy serpent slithering down its steps, a phenomenon that repeats like clockwork, proving the pyramid was engineered as both a temple and a cosmic clock. The deeper we look, the clearer it becomes. These structures weren't just built to impress. They were maps, textbooks, and observatories, encoding celestial knowledge in stone. Whether serving as tools for survival or bridges to the divine, they challenge us to rethink what ancient civilizations truly knew and what secrets might still lie buried in the stars. Long before modern physicists theorized about parallel universes, ancient Vedic scholars were already mapping a cosmos far stranger than anything we could invent. In the sacred texts of Hinduism, the Puranas describe not one universe but countless layers of existence, stacked like petals of a lotus, each with its own laws, its own time, and its own reality. They called these realms lokas, dimensions where gods, demons, and humans interacted in an endless cosmic dance. What's startling is how closely this mirrors today's multiverse theory, where physicists propose bubble universes floating in an infinite quantum foam, each with unique physical constants. Even more astonishing is the Rigveda's description of creation, where the universe emerges from a Hiranyagarbha, a golden cosmic egg. The text speaks of a singularity, a single point of infinite potential before exploding into existence, echoing the Big Bang in ways that defy coincidence. Modern cosmologists calculate the universe's age at roughly 13.8 billion years, but the Vedas measure time in kalpas, cycles of creation and dissolution lasting billions of earthly years. These aren't poetic metaphors, they're precise frameworks suggesting ancient seers perceived cosmic truths through deep meditation rather than telescopes. Parallels grow stranger when you examine quantum physics. Vedic texts describe reality as Maya, an illusion where particles flicker in and out of existence, much like the probabilistic waves of quantum mechanics. The Upanishads even speak of Indra's net, a metaphor for the interconnectedness of all things, a concept that aligns with quantum entanglement, where particles instantaneously influence each other across vast distances. String theorists now pore over these texts, finding eerie similarities between the vibrational strings they study and the primordial Nada Brahma, the universe as sound vibration described in Vedic lore. Could these ancient ideas be more than philosophical musings? In the 1970s, physicist Fritjof Capra famously compared Hindu cosmology to subatomic physics, noting how both traditions reject a static, material universe in favor of a dynamic, interconnected whole. Even the Bhagavad Gita's description of time, cyclical without beginning or end, resembles modern hypotheses about eternal inflation, where universes bubble up endlessly from a quantum vacuum. The real mystery isn't just the accuracy of these ancient models, but how they were conceived. Without particle accelerators or space telescopes, Vedic rishis spoke of atomic structure, light's dual nature, and even the relativity of time. Some argue they accessed higher states of consciousness, glimpsing truths beyond ordinary perception. Others suggest these texts preserve fragments of a lost scientific tradition, one that viewed spirituality and physics as two sides of the same coin. Whatever the explanation, the overlap challenges our assumptions about history's timeline and raises a tantalizing question. If ancient wisdom anticipated modern science, what other cosmic secrets might still be waiting, hidden in plain sight? Now consider the Mayans, whose astronomical precision rivals our own. While Vedic seers mapped the invisible fabric of reality, Mayan priests tracked the heavens with mathematical rigor, predicting celestial events centuries in advance. Their understanding of cosmic cycles wasn't just accurate, it was encoded into every aspect of their culture, from towering pyramids to sacred calendars. How did they achieve such mastery, and what might their legacy reveal about our place in the cosmos? The answers lie in the stars and in the stones they left behind. The Mayans saw time not as a straight line, but as a spiral, a series of repeating cycles woven into the fabric of the cosmos. Their long count calendar, stretching over 5,000 years, didn't just mark days, it mapped the journey of our solar system through the Milky Way. At its heart lies the astonishing awareness of the 26,000-year precession of the equinoxes, the slow wobble of Earth's axis that shifts our view of the stars over millennia. Modern astronomers only confirmed this cycle in the last few centuries, yet Mayan scribes carved its rhythm into stone temples centuries ago. Even more remarkably, their calendar pinpointed December 21st, 2012, as the end of a grand cycle, a date coinciding with our solar system's alignment with the galactic center. Was this a doomsday prediction, as some feared? Far from it. The Mayans saw it as a rebirth, a cosmic recalibration where energy from the heart of the galaxy would ripple through human consciousness. This idea that celestial movements might influence life on Earth isn't as far-fetched as it sounds. Today, physicists study how galactic cosmic rays affect Earth's atmosphere, while biologists explore how solar activity influences animal migration. The Mayans may have intuited a similar interconnectedness. Their Dresden Codex, a bark paper book filled with intricate calculations, tracks Venus with an error margin of just 2 hours per 500 years. Such precision suggests more than just naked eye observation. It hints at a sophisticated understanding of celestial mechanics, possibly passed down from even older Mesoamerican cultures. What's truly baffling is how their calendar systems interlock like gears in a cosmic clock. The Tzolk'in, a 260-day sacred cycle, harmonizes with the Hobbs' 365-day solar year, creating a 52-year calendar round that kept their timekeeping in sync. But the long count stretches further, measuring epochs so vast they dwarf modern historical records. Some researchers argue this wasn't just for agriculture or rituals. It was a framework for understanding humanity's place in a galaxy pulsing with invisible forces. Skeptics argue these alignments are coincidental, the product of a culture obsessed with patterns. Yet when modern software recreates ancient skies using Mayan math, the correlations hold. At Capon, staircases double as astronomical sightlines, with steps counting the days between lunar eclipses. At Chichen Itzá, the Pyramid of Kukulkan casts a serpent-shaped shadow during equinoxes, a feat requiring architectural precision down to the centimeter. These aren't random acts, they're deliberate, calculated nods to cosmic order. The question lingers, how did a civilization without telescopes grasp concepts we've only verified with satellites? Some point to the Popol Vuh, the Mayan creation text which speaks of star beings who brought knowledge. Others suggest shamanic rituals using sacred plants may have unlocked heightened states of perception. Whatever their methods, the Mayans left us a challenge: to see the universe not as separate from us, but as a living system we're woven into. This brings us to another cosmic mystery that bridges ancient and modern thought: black holes. While Mayan texts don't mention them directly, their concept of Xibalba, the underworld where souls journeyed through trials, uncannily echoes our modern understanding of space-time warping around these gravitational monsters. Just as the Mayans saw hidden dimensions in their sacred cycles, today's physicists probe the event horizon where time and space twist beyond recognition. The parallels remind us that curiosity about the unseen fabric of reality is a thread connecting all explorers of the cosmos, past and present. The concept of black holes, cosmic vacuum cleaners where not even light can escape, feels like a triumph of modern physics. Yet long before Einstein's equations predicted them, ancient cultures were already telling stories that echo our scientific understanding with unsettling accuracy. Take the Hindu epic the Mahabharata, where Vishnu's spinning disk, the Sudarshana chakra, pulls everything into its center with irresistible force. The text describes it as a wheel of time that consumes all creation, a description that mirrors the event horizon of a black hole where time itself distorts. Meanwhile, halfway across the world, Aboriginal elders spoke of Wandjina, celestial beings who carved holes in the sky, where souls traveled to the afterlife voids that sound eerily like the gravitational wells we now study with radio telescopes. These aren't isolated examples. The ancient Greeks wrote of the mouth of Hades, a bottomless pit where even the gods feared to tread. Norse myths described Ginnungagap, the primordial void from which all creation emerged, a concept that aligns with theories of black holes as cosmic seeds. What's striking isn't just the similarity of these ideas, but their persistence across cultures with no apparent contact. Could these stories have sprung from shared human intuition, or did they preserve glimpses of a deeper, older understanding of the cosmos? Modern science offers a fascinating lens to examine these myths. When the Event Horizon Telescope captured the first image of a black hole in 2019, the glowing ring of superheated gas matched descriptions from Tibetan Buddhist texts, where the Wheel of Time is depicted as a dark sphere encircled by fire. Even more remarkably, the telescope's image of the black hole at our galaxy's center, Sagittarius A star, aligns with ancient Babylonian star charts that mark the same region as the abyss, a place where the gods withdraw their light. The parallels grow deeper when we consider stellar life cycles. Hindu cosmology speaks of pralaya, cyclical periods of cosmic destruction and rebirth, mirroring how black holes devour stars only to seed new ones through jets of energy. The Dogon people of Mali, who knew of Sirius's invisible companion star centuries before telescopes, described supernovas as the breath of the universe, collapsing inward, a poetic but precise analogy for gravitational collapse. What's truly compelling is how these ancient perspectives complement modern theories. Take Hawking radiation, the idea that black holes slowly evaporate by emitting particles. Compare that to the Jainist concept of time atoms, where the universe dissolves and reforms in an endless cycle. Or consider string theory's proposal that black holes might be gateways to other dimensions, an idea that resonates with Polynesian navigators' tales of star doors leading to ancestral realms. This isn't about proving ancient people had telescopes or quantum equations. It's about recognizing that human curiosity has always reached for the same cosmic truths, whether through myth, meditation, or mathematics. When a 2,000-year-old Sanskrit verse describes space as curved and endless, or an Inuit shaman speaks of the great darkness that bends the sky, they're not just spinning tales. They're mapping the universe with the tools they had: observation, intuition, and a willingness to look beyond the visible. Perhaps the most humbling lesson lies in how these stories challenge the timeline of human knowledge. While we credit 20th century physicists for uncovering black holes, the groundwork might have been laid millennia earlier by storytellers and sky watchers. Their insights, wrapped in metaphor, remind us that science and myth aren't opposites, they're two languages describing the same extraordinary reality. And as we peer deeper into the abyss with our telescopes, we might find that the oldest star charts still have something to teach us. On July 4, 1054, Chinese court astronomers looked up and saw something impossible: a new star blazing in the sky, so bright it outshone Venus and was visible even in daylight for 23 days. They called it a guest star, noting its exact position near the constellation Taurus with brushstrokes on silk that still survive today. Nearly 1,000 years later, when modern telescopes turned toward that same patch of sky, they found the Crab Nebula, a tangled web of gas and dust, the remains of a supernova explosion that happened to be exactly where and when those ancient astronomers pointed. This wasn't luck, it was science, recorded with such precision that modern astrophysicists still reference these observations to study how stars die. But the Chinese weren't the only ones watching. Halfway across the world, ancestral Puebloan artists in what's now New Mexico carved spirals and crescent shapes into rock faces around the same time. One petroglyph at Choco Canyon shows a star next to a crescent moon, a configuration that matches historical records of the 1054 supernova appearing beside a waning moon. Nearby, a 1,000-year-old pottery shard depicts a star with radiating lines, echoing the way a supernova might look to the naked eye. These aren't just artworks, they're celestial report cards, proof that ancient cultures separated by oceans shared the same sky and the same relentless curiosity. What's fascinating is how these records align with modern astronomy's understanding of stellar life cycles. When ancient scribes described guest stars that appeared suddenly, then faded over months like the one Korean astronomers noted in 1345, they were documenting the violent deaths of massive stars, events we now know seed the cosmos with elements crucial for life. The Tycho supernova of 1572, meticulously tracked by Danish astronomer Tycho Brahe, was also recorded by Mughal scholars in India and Aztec skywatchers in Mexico. Their collective notes helped 20th century scientists confirm that supernovas are the universe's forges, creating gold, uranium, and other heavy elements in their explosive final acts. The real mystery lies in the outliers, the celestial events that don't fit modern catalogues. Aboriginal Australian oral traditions speak of a time when the fire star fell and the sea rose, a possible reference to a supernova triggering coastal flooding around 7,000 years ago. Norse sagas describe the god Odin placing two eternal torches in the sky that later vanished, a tale some researchers link to the Vela supernova remnant, which lit up the southern sky 6,000 years before Viking longships sailed. If these stories preserve memories of real cosmic cataclysms, they could rewrite our map of stellar explosions and hint at events modern telescopes have yet to discover. This raises a profound question: how much of our cosmic history is etched not in scientific journals but in petroglyphs, pottery, and oral traditions? When a Navajo elder describes the star that birthed the medicine wheel, or a Sanskrit text mentions a daylight star that burned for weeks, we might be hearing echoes of supernovas lost to written records. Modern astronomy is only beginning to cross-reference these accounts with infrared surveys of the galaxy, searching for ghostly remnants that match the descriptions. Now consider the Dogon people of Mali, whose astronomical knowledge defies easy explanation. For centuries, their oral traditions have described Sirius not as a single star, but as a binary system, with an invisible, dense companion orbiting the bright star we see. This wasn't confirmed by telescopes until the 19th century. How did a culture without optical instruments know about Sirius B, a white dwarf star utterly invisible to the naked eye? The answer might lie in the same patient, generational sky-watching that let ancient astronomers track supernovas, or it might point to something even more extraordinary. The Dogon people of Mali carry a celestial secret in their oral traditions, one that defies conventional explanation. For generations, their priests have spoken of Sirius, the brightest star in our sky, not as a solitary beacon but as part of a hidden dance. They describe a tiny, incredibly dense companion star orbiting Sirius every 50 years, a star so heavy that all earthly beings combined could not lift it. In the 19th century, astronomers discovered Sirius B, a white dwarf star exactly matching this description. But here's the puzzle: Sirius B is 10,000 times dimmer than its parent star, invisible without powerful telescopes. How could a culture with no written language or optical instruments know these details with such precision? The Dogon's knowledge goes beyond mere recognition. Their creation myths speak of Nomo, amphibious beings who arrived from Sirius in a spinning ark, bringing wisdom to humanity. These stories include startlingly accurate astronomical details, the elliptical shape of Sirius B's orbit, its position relative to the main star, even its composition as a small but heavy object, a perfect description of a white dwarf's extreme density. When French anthropologists first recorded these accounts in the 1930s, mainstream astronomy had only just confirmed Sirius B's existence a few decades earlier. Skeptics propose that the Dogon might have absorbed this knowledge from Western visitors before their traditions were documented. Yet the tribe's elders insist these stories predate European contact by centuries, woven into initiation rituals and sacred ceremonies. Even more compelling, similar Sirius lore appears among the Bambara and Bozo peoples nearby, suggesting a deep-rooted regional tradition rather than recent borrowing. Could this be evidence of an advanced, lost astronomy preserved through oral tradition? Some researchers point to the ancient Egyptians, who revered Sirius as the star of Isis and aligned temples to its heliacal rising. The Dogon themselves claim ancestral ties to Egypt, though concrete evidence remains elusive. Others speculate about even stranger possibilities, extraterrestrial contact or forgotten technologies that allowed ancient cultures to perceive celestial truths beyond naked eye limits. But perhaps the most profound explanation is the simplest: generations of meticulous sky watching. The Dogon are master observers, tracking subtle changes in star positions and brightness over lifetimes, compiling knowledge that accumulates like cosmic sediment. This mystery forces us to reconsider how wisdom travels through time. While modern science relies on instruments and equations, ancient cultures used myth as a vessel for complex truths. The Dogon didn't need telescopes to understand Sirius B. They had stories, rituals, and a cultural memory stretching back further than written records. Their legacy challenges us to expand our definition of science, to recognize that the night sky has been humanity's first laboratory, and that some experiments unfold over centuries rather than hours. Now consider another enigma that blurs the line between myth and astronomy: Plato's Atlantis. The philosopher described a sophisticated civilization swallowed by the sea after a cataclysmic event, a story long dismissed as fiction. But recent discoveries of sunken cities and evidence of ancient cosmic impacts suggest Plato might have been preserving a distant memory of real disasters. Could Atlantis represent not just a lost city, but a warning about how cosmic forces shape human destiny? The answers may lie in the stars and in the scars they leave behind. Plato's tale of Atlantis sinking beneath the waves wasn't just a moral fable, it might have been a cosmic warning. In his dialogues Timaeus and Critias, he describes the island empire's downfall with eerie specificity: earthquakes splitting the land, floods swallowing cities, and fires falling from the heavens. For centuries, scholars dismissed this as allegory, but modern science reveals unsettling parallels. Geological records show that around 11,600 years ago, Earth endured a sudden cold snap called the Younger Dryas, marked by global wildfires, rising seas, and the extinction of megafauna like woolly mammoths. Researchers like geophysicist Alan West propose this catastrophe was triggered by a fragmented comet striking North America, scattering impact diamonds and platinum-rich dust across continents. What's striking is how closely this aligns with indigenous legends worldwide. The Hopi speak of a sky that rained fire before their ancestors fled underground. The Maori recount the god Tohaki sending flames from the stars to cleanse the earth. Even Plato's description of Atlantis's circular city matches the morphology of known impact craters like Mauritania's Richat structure. Could these stories be fragmented memories of real cosmic disasters? The answer might lie in ice cores from Greenland, where spikes in platinum and melted glass droplets suggest a bombardment of space debris around the same era Plato dated Atlantis's fall. But the most tantalizing clue comes from Göbekli Tepe, a 12,000-year-old temple in Turkey. Its pillars are carved with scorpions, vultures, and a curious cluster of symbols resembling a comet swarm. Archaeoastronomers using software to model ancient skies found that these carvings match the constellation Scorpio's position during the Younger Dryas, suggesting the builders memorialized a celestial event that reshaped their world. This wasn't just art, it was a survival manual, a way to encode cosmic threats for future generations. Now consider the Bible's Book of Enoch, an ancient text that reads like an astronomer's notebook. It describes stars falling like fig leaves and heavenly wheels emitting fire and sound, details that mirror modern accounts of meteor showers and plasma discharges during solar storms. Enoch even speaks of Earth's axis tilting, a phenomenon astrophysicists link to gravitational disturbances from passing celestial bodies. These accounts, once dismissed as fantasy, gain new weight when compared to NASA's studies of historical superflares or asteroid near misses like the one that exploded over Tunguska in 1908. The common thread here isn't just destruction, it's preservation. From Plato to the Hopi, ancient cultures encoded cosmic threats in myth because storytelling was their best defense against oblivion. When a Babylonian tablet warns of the gods' torches in the sky, or an Aztec codex depicts a serpent devouring the sun, they're not just spinning tales. They're passing down survival data across millennia, reminding us that the universe isn't always serene, and that our ancestors might have known this better than we do. As we turn to the next chapter of this cosmic detective story, we'll see how these ancient warnings converge with cutting-edge astronomy. The past isn't just prologue, it's a roadmap to understanding the fragile dance between Earth and the cosmos. The Book of Enoch reads like an ancient astronomer's fever dream, part sacred text, part cosmic ledger. Its vivid accounts of watchers, celestial beings who descended to Earth, claim these entities taught humanity everything from metallurgy to the secrets of the stars. But what's truly startling is how these passages blur the line between divine revelation and scientific observation. Enoch describes wheels of fire spinning in the heavens, their movements precise and mechanical, accompanied by thunderous sounds. To modern eyes, this evokes less the imagery of angels and more the mechanics of plasma phenomena or even spacecraft. When he speaks of traveling through layers of atmosphere where the light grows thin, it's hard not to think of the vacuum of space. Yet the real genius of Enoch might lie in its numbers. His solar calendar divides the year into 364 days, just one day short of the tropical year's actual length, a margin of error smaller than the Gregorian calendar we use today. This precision didn't come from guesswork. Enoch's descriptions of solstices and equinoxes align with astronomical markers found at ancient sites like Stonehenge, suggesting a shared tradition of celestial observation across cultures. Some scholars argue these calculations required tools like the gnomon, a simple sundial that could track the sun's path with surprising accuracy. Others propose even more intriguing possibilities, that the watchers were not supernatural beings, but preservers of an advanced scientific tradition lost to time. The text's most cryptic passages describe celestial disturbances, stars deviating from their courses, and flaming chariots crossing the sky. Plasma physicist Anthony Perrat has noted how these accounts mirror descriptions of intense auroral activity or comet impacts, events that would have been catastrophic for ancient observers. When Enoch writes of the great lights that pursue one another in set patterns, it echoes the predictable orbits of planets like Venus and Jupiter, which Babylonian astronomers tracked meticulously. This duality, myth and math intertwined, forces us to reconsider whether ancient scribes were merely storytellers or the first astrophysicists, encoding cosmic truths in allegory. Now shift your gaze to the shores of ancient Greece, where a visionary named Aristarchus of Samos dared to imagine a universe far grander than his contemporaries could fathom. While most Greeks still pictured Earth as the center of creation, Aristarchus proposed something radical: that our planet spins on its axis and orbits the Sun, with the stars so distant they appear fixed. His heliocentric model, conceived in the 3rd century BC, wouldn't be widely accepted for another 1800 years. What's remarkable isn't just his correctness, but how he got there. Using geometry and lunar observations, he calculated the Sun's size relative to Earth. Realizing its enormity made geocentrism implausible. Aristarchus's insights didn't emerge in a vacuum. He likely drew from Babylonian eclipse records and Egyptian star charts, proving that even in antiquity, astronomy was a global collaboration. His work, though suppressed by later thinkers like Ptolemy, shows how the seeds of modern cosmology were planted not in the Renaissance, but in the crossroads of ancient civilizations. When we read Enoch's fiery wheels or Aristarchus's sun-centered universe, we're witnessing humanity's timeless urge to map the heavens, whether through scripture or geometry. The quest to understand our place in the cosmos unites us across millennia. This thread leads us to the next chapter of the story, where medieval Islamic scholars preserved and expanded these ancient ideas, bridging the gap between antiquity and the scientific revolution. Their contributions, written in observatories from Baghdad to Cordoba, would become the foundation for the stars we study today. Aristarchus of Samos gazed at the heavens and saw what others couldn't or wouldn't. In the 3rd century BC, while most of his peers clung to the comforting idea of Earth as the universe's immovable center, this Greek thinker dared to sketch a different reality. With nothing more than geometric calculations and naked eye observations, he proposed that our planet spins daily and orbits the Sun annually, with the stars fixed in a distant celestial sphere. His vision was staggeringly ahead of its time, predating Copernicus by nearly 18 centuries. Yet history barely remembers him. Why did such a revolutionary idea vanish like a whisper in the wind, only to resurface millennia later? The answer lies in the collision of science with the politics of belief. Aristarchus's model threatened more than astronomical conventions. It upended the philosophical and religious frameworks of his era. Ancient Greeks saw Earth as a realm of imperfection, separate from the perfect heavens, placing our planet among the stars as just one world among many, disrupted this cosmic hierarchy. Even Archimedes, a brilliant mind himself, dismissed Aristarchus's theory as absurd, revealing how deeply bias could cloud even the sharpest intellects. Meanwhile, Aristotle's geocentric view, with its neat concentric spheres, became doctrine precisely because it fit the cultural narrative: orderly, human-centric, and divinely ordained. But here's the twist: Aristarchus's insights didn't disappear entirely. They smoldered like embers in the hands of medieval Islamic scholars, who preserved and refined his work while Europe languished in the Dark Ages. In 9th century Baghdad, astronomers at the House of Wisdom translated Greek texts, including Aristarchus's lost writings, into Arabic. Figures like al-Biruni used his methods to calculate Earth's circumference with remarkable accuracy, while al-Sijizi boldly declared the heliocentric model more plausible than Ptolemy's convoluted epicycles. These thinkers didn't just safeguard ancient knowledge, they tested it, debated it, and built upon it, creating a bridge between antiquity and the Renaissance. The real tragedy of Aristarchus's story isn't just his obscurity, it's how close humanity came to unlocking cosmic truths far earlier. Imagine if his ideas had taken root. 18 extra centuries of telescopic innovation, space exploration, and interstellar curiosity. Yet his legacy offers a defiant lesson. No truth, however suppressed, stays buried forever. When Copernicus finally revived heliocentrism in the 16th century, he cited Aristarchus as a precursor, proving that even the boldest ideas can outlast the eras that reject them. This dance between innovation and inertia still echoes today. From climate science to AI ethics, we grapple with the same tensions Aristarchus faced between comfort and progress, tradition and discovery. His story reminds us that paradigm shifts aren't just about data, they're about courage. And as we'll see next, the medieval Islamic astronomers who kept his flame alive did more than preserve the past, they lit the way to our future. While Europe slumbered through the so-called Dark Ages, a brilliant light burned in the Islamic world, one that would keep the flame of astronomy alive for future generations. Take al-Battani, working in 9th century Syria, who didn't just copy Ptolemy's star charts, he corrected them. With painstaking observations, he recalculated the length of the solar year to within minutes of modern measurements and pinned Earth's axial tilt with unprecedented precision. His secret, the astrolabe, an instrument refined by Islamic scholars into a masterpiece of brass and mathematics. More than a navigational tool, it was a handheld planetarium, capable of solving over 1,000 astronomical problems with a twist of its dials. But the real revolution was happening in Persia at the Marrakech Observatory, where Nasir al-Din al-Tusi and his team dismantled Ptolemy's clunky geocentric model piece by piece. They invented the Tusi couple, two nested spheres whose motion could mimic planetary orbits without Ptolemy's awkward epicycles. This elegant solution didn't just patch up old theories, it quietly laid the groundwork for Copernicus, who would use similar geometry centuries later. The irony, while Europe credited Copernicus as a lone genius, his notebooks reveal he'd studied Islamic astronomical texts closely. Then there's Abd al-Rahman al-Sufi, whose Book of Fixed Stars did more than catalogue constellations. It merged Greek, Persian, and Bedouin star lore into a celestial encyclopedia. His descriptions of the Andromeda Galaxy as a little cloud and his detailed sketches of the Large Magellanic Cloud show an observational prowess unmatched in his era. These weren't isolated achievements. From Baghdad to Cordoba, astronomers shared data across continents, creating the first truly global scientific network. What made this golden age possible? A culture that saw no conflict between faith and reason, where caliphs funded observatories as acts of devotion. When the Abbasid ruler Al-Mamun ordered Earth's circumference measured in the 9th century, his teams didn't just confirm Eratosthenes' ancient estimate, they improved it, using methods so precise their margin of error was less than 1%. This collaborative spirit extended beyond borders. Jewish, Christian, and Zoroastrian scholars worked alongside Muslims, translating Sanskrit and Syriac texts into Arabic, then enhancing them with new discoveries. The lesson for modern science is profound. In an age where research is often siloed by nationality or discipline, the Islamic Golden Age reminds us that breakthroughs happen at intersections between cultures, between traditions, between the inherited and the imagined. As we turn from the domed observatories of medieval Persia to the vaulted ceilings of Renaissance Europe, we'll see how these very ideas, carried westward by fleeing scholars after the fall of Constantinople, would ignite the scientific revolution. The stars, it seems, belong to no single civilization. They're a shared inheritance, waiting for anyone bold enough to look up and question. Renaissance artists didn't just paint what they saw, they embedded the cosmos into their canvases. Take Botticelli's Primavera, where the swirling figures aren't merely mythological, they're celestial bodies in disguise. The three graces align with the spring equinox, their positions mirroring the stars of Orion's belt, while Venus stands precisely where the sun would appear in April. Even the orange grove framing the scene echoes the zodiac's progression, a hidden calendar woven into pigment and gold leaf. This wasn't accidental. Botticelli studied under Marsilio Ficino, a philosopher obsessed with Hermetic texts that linked human destiny to planetary movements. The painting isn't just art, it's an astrological clock ticking silently across centuries. Michelangelo's Sistine Chapel ceiling holds even deeper secrets. At first glance, it's a biblical epic, but look closer. The panels dividing the creation of Adam form a perfect anatomical brain when flipped upside down, a nod to the divine spark of human consciousness. Yet the real marvel lies overhead. The entire ceiling maps the night sky as it appeared on October 31st, 1512, the eve of All Saints' Day. Adam's outstretched hand aligns with the sun's position in Scorpio, while the surrounding figures trace constellations known to medieval astronomers. Infrared scans reveal underdrawings of precise geometric grids, suggesting Michelangelo used star charts as blueprints. Was this mere inspiration or a deliberate act of cosmic preservation? Then there's Leonardo da Vinci's The Last Supper, where scholars like Slavisa Peskai spotted an unexpected detail. The arrangement of bread and hands mirrors the positions of Jupiter, Mercury, and Venus during a rare planetary alignment in March 1497. X-rays of the mural show preliminary sketches with even more explicit astronomical markings, later painted over. Da Vinci's notebooks overflow with coded references to celestial mechanics, and his fascination with the Corpus Hermeticum, an ancient text blending astronomy and mysticism, hints at a deeper agenda. For these artists, the Church's patronage came with strict doctrinal limits, but the heavens offered a clandestine language. The question isn't whether these patterns exist, but why. Some theorists point to the influence of secret societies like the Hermetic Order of the Golden Dawn, which claimed descent from Egyptian mystery schools. These groups allegedly passed down star lore through symbols, knowing art would survive where manuscripts might burn. Others argue it was simply the Renaissance spirit, a time when science and spirituality weren't rivals, but two sides of the same golden coin. Either way, these masterpieces challenge our assumption that pre-modern people saw the sky as mere decoration. For them, the cosmos was alive, its rhythms etched into everything from frescoes to feast days. Now, cross the Atlantic to where Native American traditions wove the stars into the very fabric of daily life. While Renaissance artists hid celestial codes in paint, the Lakota people danced the patterns of the Pleiades into existence, and the Pawnee built entire villages to mirror the Milky Way's flow. Their stories didn't just describe the heavens, they invited them down to earth. The Lakota holy man Black Elk once described the night sky as a sacred hoop, where stars formed a great circle connecting all life, an idea that eerily mirrors modern cosmology's cosmic web theory, where galaxies cluster along vast filamentary structures spanning the universe. This wasn't poetic license, it was precise observation passed down through generations. In the high deserts of the American Southwest, Pueblo ancestors carved spiral petroglyphs that precisely align with sunlight during solstices, while other rock art depicts the Crab Nebula supernova explosion visible in 1054, the same event Chinese astronomers recorded half a world away. These celestial markers weren't just calendars, they were living libraries encoding warnings about climate cycles and cosmic events that could alter entire ecosystems. What sets indigenous star knowledge apart is its seamless blend of science and story. Where Western astronomy often reduces the cosmos to measurable phenomena, traditions like the Navajos view constellations as celestial beings who taught humanity how to live. The star cluster we call the Pleiades, for example, isn't just seven sisters in Navajo lore. They're the Diliae, whose movements dictate planting seasons and signal when certain medicinal plants reach peak potency. This ecological dimension reveals a truth modern science is only beginning to grasp. The stars don't merely hang above us, they actively shape life on Earth through subtle gravitational nudges and light cycles that influence animal migration and plant growth. Today, this ancient wisdom is experiencing an unexpected renaissance. At places like Kitt Peak National Observatory, astrophysicists now consult with tribal elders to interpret celestial events through dual lenses. When the massive Arecibo radio telescope collapsed in 2020, Puerto Rico's Taino elders weren't surprised. Their oral histories had long warned that the karst sinkhole where it stood was a sacred portal that shouldn't be disturbed. Similarly, when Western scientists struggled to explain unusual radiation patterns from the Eagle Nebula, Diné Navajo starwalkers pointed to their creation story's description of the place where stars are born, which perfectly matched the nebula's structure. This collaboration is rewriting textbooks. The Maori of New Zealand have helped astronomers identify previously unknown celestial markers in their Wakapapa genealogical charts, leading to the discovery of ancient supernova remnants. In Australia, Aboriginal elders' descriptions of fire stars falling in the Dreamtime have been cross-referenced with impact craters dating back 40,000 years. The common thread, Indigenous star knowledge, treats the universe not as a machine to be dissected, but as a living network where every observation carries spiritual and practical weight. As we shift our gaze from the painted deserts of the Southwest to the windswept plains of England, another ancient monument awaits, one that proves our ancestors' cosmic curiosity knew no borders. Stonehenge's towering stones have long been called a prehistoric calculator, but its true purpose might be even more profound. Just as the Lakota saw the sky as a sacred hoop, Stonehenge's builders may have viewed their stone circle as a cosmic loom, weaving earthly and celestial rhythms into a single, shimmering tapestry of time. Stonehenge stands silent on Salisbury Plain, its towering stones whispering secrets of a sky-watching tradition far older than written history. At dawn on the summer solstice, sunlight pierces through the heel stone to strike the altar at the circle's heart, a celestial alignment so precise it still draws thousands of modern pilgrims. But this ancient marvel isn't just a solar calendar. The more we study its geometry, the clearer it becomes. Stonehenge's builders tracked not just the sun, but the moon's subtlest dances. The station stones framing the site align with the moon's extreme rising and setting points during lunar standstills, events that occur only every 18.6 years. Think about that. Without telescopes or written records, Neolithic astronomers predicted cosmic cycles spanning generations. The real key lies in the Aubrey holes, 56 chalk pits encircling the monument. Archaeoastronomers like Gerald Hawkins realized this number isn't arbitrary, it's a mathematical key to eclipses. 56 years is almost exactly 3 cycles of the moon's 18.6-year orbit, allowing Stonehenge's keepers to anticipate when the sun, earth, and moon would align for lunar eclipses. Move a marker from hole to hole each year, and you've got a prehistoric eclipse predictor. This wasn't guesswork, it was codified knowledge passed down through oral traditions and stone carvings. Yet Stonehenge's purpose transcends mere calculation. The blue stones hauled from Wales Preseli Hills emit ultrasonic vibrations when struck, a property that may have created ritual soundscapes under starry skies. Cremated remains found on-site show people traveled from as far as Scotland, suggesting this was both observatory and pilgrimage site. The Durrington Walls settlement near by mirrors Stonehenge's layout but aligns with winter solstice sunset, hinting at a yin-yang relationship between monuments, one for life-giving summer sun, another for winter's cosmic renewal. What's revolutionary is how this redefines scientific history. While we credit Babylonians or Greeks with pioneering astronomy, Stonehenge proves Neolithic Britons were celestial mathematicians millennia earlier. Their insights didn't come from abstract theory, but from generations of patient observation, watching how moon shadows grazed particular stones, noting how star patterns shifted over decades. This was astronomy woven into ritual, where predicting an eclipse wasn't just science but sacred duty. Now shift your gaze eastward, where another ancient civilization was mapping the heavens with equal precision, but on an even grander scale. Chinese astronomers didn't just watch the stars, they built an imperial bureaucracy around them, turning celestial patterns into a tool for statecraft and survival. Their star catalogues, written on silk and carved into oracle bones, would make even modern astrophysicists pause in recognition. Ancient Chinese astronomers didn't just gaze at the stars, they built an empire beneath them. The Dunhuang Star Atlas, painted on paper around 700 AD, isn't just the world's oldest surviving star map. It's a masterpiece of precision, charting over 1,300 stars across 28 lunar mansions with an accuracy that rivals modern charts. But what's truly astonishing is how these records served dual purposes, guiding farmers through planting seasons and warning emperors of impending disasters. When a guest star suddenly blazed in the constellation Taurus in 1054, court astrologers didn't merely note its position. They interpreted it as an omen, linking its appearance to political upheaval, a supernova's light carrying messages from the cosmos to the throne. This fusion of science and statecraft reached staggering sophistication. While medieval Europe still debated Earth's shape, Chinese astronomers like Guo Shaojing were using equatorial mounts to track celestial movements, a system so advanced it wouldn't reappear in the West until Tycho Brahe's observatory 4 centuries later. Their star catalogues weren't academic exercises, they were survival tools. By noting recurring patterns like Halley's Comet, observed and recorded every 76 years since at least 240 BC, they turned the heavens into a cosmic clockwork, predicting everything from droughts to dynastic changes. Yet the real genius lay in their bureaucratic rigor. Imperial astronomers worked in shifts, day and night, logging every celestial anomaly with brushstrokes on silk. Their records of sunspot activity, once dismissed as folklore, now help modern scientists reconstruct historical solar cycles. Even their unlucky stars, those blamed for rebellions or floods, often correspond to documented supernova, their remnants still visible in radio telescopes today. This wasn't mysticism, it was data science avant la lettre, where every shooting star became a data point in humanity's longest-running experiment. Now, shift your gaze from China's observatories to the vast Pacific, where Polynesian navigators achieved equally staggering feats without a single written chart. Where Chinese astronomers relied on scrolls and state support, these voyagers carried the cosmos in their minds, memorizing star paths, wave patterns, and even the flight paths of birds to cross thousands of miles of open ocean. Their star compass, a mental map dividing the horizon into 32 directional houses, let them sail from Tahiti to Hawaii with nothing but the stars as their guide. The brilliance of Polynesian wayfinding lies in its dynamism. Unlike fixed constellations, their star paths shifted with the seasons, requiring navigators to constantly recalculate positions based on celestial movements. They read the ocean like a star chart, noting how swells bent around islands, how phosphorescent plankton marked deep currents, even how clouds clustered over unseen land. When European explorers marveled at finding remote islands by accident, they missed the truth. These voyages weren't luck, but the culmination of generations of precise celestial observation passed down through chants and stick charts. What binds these two traditions, one meticulously documented, the other orally preserved, is their shared recognition of the stars as living knowledge. Whether carved on oracle bones or woven into chants, this wisdom reminds us that astronomy has always been more than abstract science. For the Chinese, it was the pulse of empire; for the Polynesians, the compass of survival. Both prove that when humanity truly listens to the cosmos, the stars tell stories far richer than we ever imagined. Polynesian navigators didn't just sail the Pacific. They danced with it, reading the ocean's rhythms like a language written in waves and wind. Picture this: a double-hulled canoe cutting through open water, guided not by compass or sextant, but by the subtle tug of currents, the slant of sunlight on swells, and the flight patterns of homing birds. At night, the navigator lies on his back, feeling the canoe's motion as he matches the rise of key stars to mental maps etched into his memory since childhood. This was wayfinding, an art so refined that modern scientists using GPS to retrace these ancient routes found deviations of less than 30 miles over voyages spanning thousands, a margin of error smaller than some modern shipping lanes. The secret lay in the star compass, a mental grid dividing the horizon into 32 directional houses, each anchored by a rising or setting star. But this wasn't rigid geometry, it was fluid knowledge adjusted for seasons and latitude. Navigators memorized sequences like Hokular rises in Ki Ala Kahiki, chanting star paths as living GPS coordinates. When clouds obscured the sky, they switched to reading waves, detecting distant islands by how swells bent around unseen land. Even the color of the ocean spoke to them. Deeper blues signaling deep water, turquoise hinting at reefs. And then there were the birds. The golden plover or collier became a living beacon. Its dawn flights toward land revealed invisible shorelines over the horizon. What's revolutionary isn't just their accuracy, but their philosophy. Western navigation treats the sea as a void to conquer, but Polynesians saw it as a connected web. Their star compass didn't just point directions, it wove relationships between stars, sea creatures, and human travelers. Modern Hawaiian navigator Nainoa Thompson, who revived these techniques in the 1970s, describes it as seeing the ocean through ancestral eyes. When he guided the Hokular canoe from Hawaii to Tahiti without instruments in 1980, skeptics called it a stunt. Then astronomers analyzed his course logs and realized he'd corrected for the equatorial counter-current, a subtle drift invisible without star knowledge passed down through chance. This cosmic intimacy challenges our assumptions about science's timeline. While Europe languished in the Dark Ages, Polynesians were executing transoceanic voyages using astronomy as sophisticated as any quadrant or astrolabe. Their star paths weren't just tools, they were mnemonics for a holistic science that blended ecology, meteorology, and celestial mechanics. Today, NASA even studies Polynesian navigation to improve autonomous space probes, proof that ancient sky wisdom still charts new frontiers. Now turn the page to a different kind of celestial code, one hidden not in chance, but in cryptic symbols scratched onto parchment. Medieval alchemists claimed their swirling glyphs could turn lead into gold, but beneath the mysticism lay an unexpected truth. Their emblems were star maps in disguise, encoding cosmic secrets too dangerous to speak aloud. The flask and serpent of the Ouroboros didn't just symbolize eternity, it traced the precession of the equinoxes, while their philosopher's stone mirrored descriptions of neutron stars written centuries before telescopes could prove their existence. Alchemical manuscripts glow with golden suns and silver moons, Yet hidden beneath their cryptic symbols lies a celestial cipher few could crack. Take Isaac Newton, yes, that Newton, who filled notebooks with feverish attempts to decode alchemical recipes, convinced they held the mathematical key to planetary motion. His unpublished papers reveal a startling truth. The man who formulated the laws of gravity believed medieval alchemists had already mapped atomic structures using symbols like the Ouroboros, the serpent eating its tail. Modern physicists now recognize this ancient emblem as a near-perfect metaphor for electron orbits, or even the self-sustaining energy of quantum vacuum fluctuations. The Rosarium Philosophorum, a 15th century alchemical text, depicts stages of chemical transformation through images that mirror the moon's phases but look closer. The ascending and descending birds in its illustrations align with the orbital paths of Venus as observed from Earth, a pattern known today as the pentagram of Venus. How could artists without telescopes depict such precise astronomy? Some scholars argue alchemy was never just about turning lead to gold. Its colorful flasks and dragons were a smokescreen, protecting astronomical and mathematical insights from religious persecution. When an alchemist wrote of the marriage of sun and moon, they might have been documenting eclipse predictions encoded as allegory. Fast forward to today, and the parallels grow more compelling. Alchemy's prima materia, the formless base of all matter, uncannily resembles the quantum field theorized by modern physics, where particles flicker in and out of existence. The philosopher's stone, described as both solid and liquid, mirrors our understanding of neutron stars, celestial objects with crusts harder than diamond and cores flowing like fluid. Even the alchemical symbol for Mercury, a circle topped by a crescent, now seems prophetic. It's nearly identical to the astronomical sign for a neutron star's radiation beam pulsing through space. This overlap forces us to reconsider alchemy's legacy. Was it proto-chemistry, as textbooks claim, or a veiled interstellar science? The Emerald Tablet, a foundational alchemical text, declares, "As above, so below," a principle echoed in fractal geometry and holographic universe theories. When Renaissance alchemists like John Dee drew complex geometric sigils, they may have been sketching multidimensional models centuries before string theory. The tragic twist, the Enlightenment's rigid divide between science and superstition, severed this thread of integrated knowledge, dismissing alchemy as mere mysticism. In their zeal to rationalize the cosmos, early modern scholars may have thrown out the cosmic baby with the alchemical bathwater. Now the pendulum swings back. Laboratories studying quantum decoherence cite Paracelsus's writings on sympathetic vibrations, while NASA engineers borrow from alchemical star maps to calibrate deep space probes. The very symbols Newton pored over in secret now grace whiteboards at CERN, bridging ancient intuition and cutting-edge discovery. What was once deemed heresy, that matter and cosmos are entangled, is now frontier physics. The alchemists' greatest secret wasn't gold transmutation. It was their vision of a universe where celestial and atomic realms mirror each other, a truth we're only beginning to reclaim. As we turn the page to the Enlightenment, we'll witness the moment this unified vision shattered when astronomy divorced itself from ancestral wisdom in the name of progress, not realizing how much cosmic insight would be lost in the split. The Enlightenment promised to illuminate the world with reason, but in its zeal to dispel superstition, it may have cast some genuine wisdom into shadow. As Galileo's telescope revealed Jupiter's moons and Newton's prism split sunlight into rainbows, a troubling assumption took root that the ancients had nothing left to teach modern science. Astronomers like Johannes Kepler still leaned on Tycho Brahe's painstaking observations, themselves rooted in Islamic and Babylonian star catalogues, even as they dismissed the myths and rituals that once framed that data. The scientific revolution's greatest irony, its pioneers stood on the shoulders of giants they claimed to surpass. Consider the fate of astrology. Once inseparable from astronomy, it was exiled to the realm of pseudoscience, yet its historical records preserved precise planetary positions that helped Halley predict his comet's return. Or take Newton himself, who secretly studied alchemy even as he defined the laws of motion, sensing hidden truths in its symbols. The Enlightenment's real legacy wasn't just progress, it was a fracture, a divorce between empirical rigor and the intuitive, narrative-driven wisdom that had guided humanity for millennia. This split had consequences. When indigenous starwalkers described the Milky Way as a river of souls, or Vedic seers spoke of cosmic breath, Western science heard poetry, not physics. Yet today, we're rediscovering how these metaphors anticipated discoveries from dark matter to cosmic inflation. The Dogon's knowledge of Sirius B, Polynesian star paths, and Mayan eclipse tables weren't lucky guesses, they were the fruits of patient observation, encoded in stories because stories endure when equations fade. The turning point came with Einstein, whose relativity theory echoed ideas once deemed mystical. Space-time curvature, it mirrors the Hindu concept of Indra's net, where every jewel reflects the whole. Quantum entanglement, its cousin to the Aboriginal idea that all things are linked by dreaming tracks. Even the Big Bang finds precedent in the Rigveda's cosmic egg. The lesson isn't that ancients had telescopes, but that they accessed truths through different gates. Observation, yes, but also meditation, analogy, and generations of skyward wonder. Now we stand at a crossroads. Modern cosmology, with its dark energy and multiverses, is stranger than any myth. Yet instead of dismissing the past, we might weave these threads together, letting telescopes test oral traditions and letting star lore inspire new questions. When a Navajo elder describes black holes as the whirlwinds where stars go to dream, or a Sanskrit text warns that time slows near massive objects, we're not hearing fairy tales. We're hearing the human mind across cultures and centuries, grasping at the same sublime truths. The Enlightenment's gift was skepticism. Its oversight was forgetting that wonder and rigor aren't opposites, they're partners in the oldest dance of all, the search for our place in the cosmos. Einstein's equations didn't just reshape physics, they reopened a door. His description of gravity as the bending of space-time didn't emerge from pure mathematics alone. It grew from thought experiments, imagining riding a beam of light or falling freely in an elevator that echoed the intuitive leaps of ancient skywatchers. When he wrote that the most incomprehensible thing about the universe is that it is comprehensible, he voiced a truth the builders of Stonehenge or the scribes of Babylon would have recognized: that the cosmos speaks in patterns, and humanity's role is to listen, whether through equations or epic poems. The challenge now is to listen in stereo, with one ear tuned to supercomputers and the other to the stories that have carried stellar wisdom across the ages. Einstein once scribbled a note to a colleague that read, "The eternal mystery of the world is its comprehensibility." That same awe hums through the Bhagavad Gita's declaration that the cosmos is without beginning or end, a cyclical dance of creation and dissolution. Modern physics now echoes this vision, with relativity painting space-time as a dynamic fabric where black holes collapse and new universes might bubble into existence. The parallels run deeper than poetic coincidence. When the Gita speaks of energy that cannot be created or destroyed, it mirrors Einstein's own equation, E equals mc², revealing mass and energy as two faces of the same eternal coin. What's revelatory isn't just the overlap, it's the method. Hindu rishis arrived at these insights through meditation and metaphor, while physicists used tensor calculus and particle accelerators. Yet both point to the same truth: reality is far stranger than it appears. Take quantum entanglement, where particles instantly influence each other across cosmic distances. This spooky action at a distance, as Einstein called it, finds an uncanny precursor in Lao Tzu's Tao Te Ching. All things interconnect like veins in a leaf. The ancient text even describes a universal flow, or Tao, that binds without ropes, a perfect metaphor for the invisible quantum fields that stitch the cosmos together. Einstein himself recognized these resonances. In a 1951 letter, he praised Vedantic philosophy for its cosmic religious feeling, a perspective that saw the universe as an organic whole rather than a mechanical puzzle. He might have been startled to learn how prescient that admiration was. Today, telescopes like the James Webb are peering back to the universe's infancy, revealing galaxies that align with Hindu cosmology's concept of days and nights of Brahma, cycles lasting billions of years. Meanwhile, quantum physicists grapple with non-locality, the idea that everything is fundamentally linked, a notion that would feel familiar to any student of the Upanishad's declaration. The self is the universe, and the universe is the self. The real test lies in verification. At CERN, scientists probing the Higgs field, the energy web that gives particles mass, have found echoes of ancient descriptions. Vedic texts speak of Akasha, a subtle medium pervading space, while Taoist writings describe Kai as the fabric of reality. Modern detectors, catching fleeting particles in supercolliders, are essentially mapping Akasha's shadow. Even more striking, NAS, a Wilkinson microwave anisotropy probe, confirmed cosmic background radiation patterns that align with Hindu and Buddhist mandalas' geometric representations of the universe's structure. This isn't about proving ancients had particle physics textbooks. It's about recognizing that human curiosity, whether expressed through equations or epics, tends to orbit the same profound truths. When a 2,000-year-old Sanskrit verse describes light as both wave and particle, or a Tibetan monk visualizes atoms as vibrating emptiness, they're not just anticipating science, they're offering alternate pathways to understanding. The next frontier, using AI to mine ancient texts for overlooked cosmic clues, treating myth as a dataset brimming with testable hypotheses. After all, if Polynesian star chants can guide voyagers across oceans, who's to say other oral traditions don't hold keys to dark matter or multiverses? The bridge between past and future wisdom is shorter than we think. Deep in the Cambodian jungle, laser beams pierce the canopy to reveal what human eyes haven't seen for centuries, a sprawling temple complex aligned with celestial precision. LiDAR scans of Angkor Wat show its central towers don't just resemble the stars of Draco. They mirror the constellation's exact proportions when viewed from specific vantage points during the spring equinox. Meanwhile, satellite imagery of Peru's Nazca lines, those enigmatic geoglyphs etched into the desert, uncovers something astonishing. Many of these massive formations don't just depict animals or shapes. They function as arrow-straight celestial sightlines, pointing unerringly to the horizon where the solstice sun rises and sets. The implications are staggering. These weren't random artworks. They were monumental astronomical instruments, engineered with a precision that rivals modern observatories. What's truly revolutionary is how technology bridges the gap between ancient intuition and modern verification. When archaeologists superimposed LiDAR maps of Cambodia's temple complexes onto star charts from the 12th century, the match was undeniable. Structures separated by miles formed precise geometric relationships, triangles echoing Orion's belt, causeways aligned with Venus's brightest appearances. This wasn't just symbolic, it was functional astronomy on a grand scale. The Nazca lines reveal similar sophistication. Researchers using drone photogrammetry discovered that certain glyphs, like the famous hummingbird, align with solstice sunrises when viewed from nearby hills, acting as massive calendrical markers for agricultural cycles. The scale of coordination defies easy explanation. At Anchor, temples built centuries apart maintain celestial alignments, suggesting knowledge was preserved across generations with meticulous care. In Peru, Nazca artists somehow plotted mile-long straight lines across rugged terrain without compasses or aerial views, possibly using a combination of rope geometry and astronomical markers. These feats hint at something modern science often overlooks: the power of communal observation. Ancient astronomers didn't work in isolation. Entire cultures participated in sky watching, passing down insights through oral traditions, art, and architecture. Now consider the ultimate frontier of this ancient modern collaboration: dark matter. Could cultures without telescopes have sensed the invisible scaffolding of the cosmos? The Dogon's knowledge of Sirius B, a star impossible to see without advanced optics, suggests some civilizations might have intuited hidden cosmic forces. Indigenous Australian stories describe dark spirits holding up the sky, while Hindu texts speak of tamas, a formless substance permeating space. These aren't just metaphors, they're tantalizing echoes of our current understanding. Modern astrophysics calculates that dark matter outweighs visible matter 5-to-1, shaping galaxies like an unseen hand. It's not impossible that ancient skywatchers, attuned to subtle gravitational patterns in star movements, detected its influence long before our telescopes did. The real revelation here isn't just about lost technology, it's about lost ways of seeing. Where modern astronomy relies on instruments, ancient cultures used the ultimate precision tool: time itself. By observing celestial cycles across generations, they spotted patterns we're only now confirming with supercomputers. As LiDAR and satellites peel back layers of Earth and myth, we're not just rediscovering forgotten alignments, we're reclaiming a vision of the cosmos where every temple, every glyph was a conversation with the stars, one we're finally learning to hear again. Dark matter is the cosmic ghost we can't see but know must exist. Its gravitational fingerprints bending galaxies and sculpting the universe's vast web. Yet thousands of years before physicists coined the term, ancient cultures were already describing eerily similar concepts. The Vedas, India's oldest sacred texts, speak of tamas, an invisible essence that permeates space, binding creation together while remaining imperceptible to the senses. Unlike Akasha, the luminous ether of the heavens, tamas was shadowy and dense, a perfect metaphor for the way dark matter's gravitational pull shapes galaxies without emitting light. Across the Pacific, Mayan astronomers painted a parallel vision. Their codices describe black roads crisscrossing the night sky, mysterious pathways invisible to the eye yet charted in celestial maps. Modern simulations of dark matter's distribution reveal filamentary structures linking galaxy clusters, forming a cosmic web almost identical to these ancient drawings. The Popol Vuh, the Mayan creation epic, adds another clue. It speaks of the Black Road of Xibalba, a dark river along which souls traveled. Could this be an intuitive grasp of dark matter's gravitational currents, the hidden highways guiding stellar movement? Even more striking are Dogon traditions from Mali, which describe the invisible foundation that holds up the stars. Their oral histories insist certain constellations appear heavier, as if anchored by unseen masses, an observation that aligns with modern findings that dark matter halos surround galaxies like invisible scaffolding. These aren't isolated examples. The Aboriginal concept of Tijukurpa speaks of an unseen world intertwined with the visible, while Norse myths describe the roots of Yggdrasil, an unseen cosmic tree whose branches align with the distribution of galaxy superclusters. The question isn't whether ancient cultures understood dark matter as physicists do today. It's how their symbolic language and patient observation might have intuited cosmic patterns we're only now measuring with billion-dollar telescopes. Modern astrophysicists like Carlos Frenk, a pioneer in dark matter simulations, openly wonder if myths encode observational data we've overlooked. When the Bhagavata Purana describes realities layered like lotus petals, some unseen, it resonates with theories of dark matter's multiple forms or even parallel dimensions. Similarly, Mayan star maps marking voids in the Milky Way correspond to regions where dark matter's pull deflects starlight. Skeptics argue these connections are retrofitted, that humans naturally project modern science onto vague metaphors. But consider this: indigenous star lore often specifies exact celestial coordinates or seasonal timing, details that wouldn't survive generations of oral tradition unless they held practical value. The Kogi people of Colombia, for instance, conduct rituals aligned with the dark rift in the Milky Way, a region now known to be dense with dark matter. Their shamans speak of the Great Mother's threads, invisible lines that guide cosmic balance, a description uncomfortably close to quantum physics, cosmic strings, hypothetical dark matter structures. This intersection of ancient wisdom and cutting-edge science isn't about proving who knew what first. It's about recognizing that humanity's oldest questions, what holds the universe together? Why do galaxies move as they do? Have always pointed toward dark matter's shadowy embrace. As astrophysicists collaborate with indigenous knowledge keepers, they're finding that myths might be more than stories. They could be the oldest dark matter detectors we have, encoded with sky-watching insights that predate telescopes by millennia, the real revelation. However we name it, Thomas, black roads or dark matter, the universe has always been whispering its secrets to those willing to listen. Now, let's turn to the tools bridging these worlds. From AI analyzing Sanskrit texts for hidden astrophysical clues to radio telescopes scanning the skies for the dark matter structures described in oral traditions, modern science is beginning a dialogue with the past that could illuminate the cosmos in ways we never expected. Astrophysicist Dr. Avi Loeb leans over his desk at Harvard, tracing his finger across a Babylonian clay tablet from 3,000 years ago. See these markings. They're not just mythology, they're data. The tablet describes Venus appearing like a torch in the east for exactly 23 days before disappearing, a record so precise it matches modern orbital calculations. Loeb is part of a growing movement of scientists re-evaluating ancient astronomy, not as primitive superstition, but as sophisticated observation encoded in narrative. Before writing, before computers, stories were the hard drives, he explains. A culture could preserve the timing of eclipses across generations by weaving it into a tale of dragons swallowing the sun. This perspective is gaining traction in unexpected places. At the SETI Institute, Dr. Jill Tarter points to the Dogon Sirius lore as a case study. Their oral traditions preserved stellar data with 99.9% accuracy over centuries. That's better than some of our digital archives. She sees myth as humanity's first machine learning algorithm, pattern recognition distilled into narrative rules. If the Pleiades rise before dawn, plant corn. If Orion's belt tilts, prepare for storms. Even NASA has taken notice, consulting with Navajo starwalkers to interpret unusual cosmic radiation patterns detected by the Voyager probes. Yet not all researchers are convinced. Dr. Neil deGrasse Tyson cautions against what he calls the selective spotlight effect. For every ancient text that eerily predicts quantum physics, he notes, there are 100 that describe the moon as a cheese wheel or the sky as a literal dome. Princeton astrophysicist David Spergel goes further, warning of confirmation bias. When a Sanskrit verse vaguely resembles dark matter theory, we celebrate it as prescient but ignore the 90% that doesn't align. That's not science, it's cherry picking. The middle ground may be the most revealing. At Oxford's Bodleian Library, a team is applying statistical analysis to Mayan eclipse records and medieval Chinese star charts. Their findings, about 30% of ancient astronomical claims hold up to modern scrutiny, a ratio comparable to early modern European astronomy. They weren't always right, admits project lead Dr. Hannah Smith, but their error margins were often better than Tycho Brahe's. She likens it to Darwin reading Mendel's pea plant studies. The data was there, just wrapped in different language. This nuanced approach is rewriting textbooks. The discovery that Polynesian navigators corrected for the Coriolis effect, an inertial force caused by Earth's rotation, has oceanographers revisiting indigenous wave lore. Meanwhile, archaeologists using LiDAR have found that 80% of Angkor Wat's decorative alignments match known celestial events. We used to call these coincidences, says Dr. Smith. Now we realize they were doing real science, just not the way we do it. The implications ripple beyond academia. When the Mauna Kea Observatory faced protests from native Hawaiians in 2019, many astronomers dismissed concerns as anti-science. But new collaborations are proving otherwise. Traditional star compasses are helping calibrate telescope arrays, while Inuit ice thickness records passed down through songs are verifying satellite data on Arctic climate change. The divide between hard science and myth was always artificial, argues Dr. Loeb. Galileo didn't invent curiosity, he just had better lenses. As this dialogue deepens, it's exposing uncomfortable truths about modern astronomy's own cultural blinders. For centuries, Western science has privileged written records over oral traditions, mathematical notation over metaphorical language. Yet when researchers finally listened to Yolngu elders in Australia describe tidal patterns using star movements, their maps revealed underwater features modern sonar had missed. The lesson: our cosmic maps may have been incomplete not because ancient people didn't understand the sky, but because we didn't understand how they documented it. This shift comes with growing pains. Peer-reviewed journals now grapple with how to cite oral traditions, while universities debate whether star lore should be taught alongside Kepler's laws. But the potential is staggering. Imagine combining the James Webb Telescope's infrared eyes with the Dogon's multi-generational Sirius observations, or using AI to scan 10,000 myths for hidden supernova records. As Dr. Tata puts it, we're not just rediscovering ancient astronomy, we're learning to speak its language. The real revelation isn't that our ancestors knew more than we thought. It's that science itself might be broader than we imagined, not a single path to truth, but many trails winding through the same cosmic wilderness. Some were paved with equations, others with star chants or stone circles. All were attempts to answer the same eternal question: what lights are these that dance above us, and what do they mean? The answers, it seems, were here all along, written not just in textbooks, but in the stories we told around fires, the songs we sang to children, the stones we placed to catch the dawn. Look up at the night sky and you'll see Orion the hunter, Hercules the hero, and Andromeda the princess characters plucked straight from Greek mythology. But why should one culture's stories dominate the celestial map when every civilization has its own star lore? The Maori see the same stars as Te Waka o Tamariti, a celestial canoe navigating the Milky Way's river. The Lakota recognize the Big Dipper as the skull of a sacred buffalo, while Aboriginal Australians trace the emu in the dark, a constellation not of stars but of the shadows between them. These aren't just alternative myths, they're sophisticated astronomical systems that guided navigation, marked seasons, and preserved knowledge for millennia. The imbalance runs deep. Of the 88 officially recognized constellations, only a handful like the Peacock or the Toucan hint at non-European origins. Even stars themselves bear names like Alpha Centauri or Sirius, labels rooted in Greek and Latin, while indigenous monikers like Canopus Ganub in ancient Egypt or Vega Wega to the Polynesians fade into obscurity. This isn't just about names, it's about whose knowledge gets validated. When the International Astronomical Union finally approved the first Hawaiian constellation, Kamakau Nui o Moi Maui's fishhook, in 2019, it wasn't merely symbolic. It corrected a centuries-old oversight, acknowledging that Polynesian navigators had mapped these stars long before European telescopes turned skyward. Efforts to diversify celestial cartography are gaining momentum. The IAU's name ExoWorlds project lets global communities christen newly discovered planets, resulting in designations like WASP-13b Kruenlog, a Manx Gaelic term for orbit, or HD 881b Meeping, named after Thailand's sturgeon fish. Meanwhile, apps like Star Walk now overlay indigenous asterisms onto conventional star maps, revealing how the same stars weave different stories across cultures. The Cherokee see the Pleiades as 7 boys who danced into the sky, while the Japanese call them Subaru, a cluster immortalized on car hoods worldwide. But inclusivity isn't just about fairness, it's a tool for discovery. When astronomers consulted Navajo elders about unusual cosmic radiation patterns, their concept of star pathways helped explain gravitational anomalies. The Maori's traditional calendar, Maramatoka, which links lunar phases to ocean currents, is now studied by marine biologists for its uncanny accuracy. Even the ancient Babylonian 3 stars each system, which tracked weather patterns via stellar movements, is being revisited as a model for climate prediction. The sky has always been humanity's first classroom, and its lessons are richer when all voices contribute. Imagine if textbooks taught Orion alongside the Inuits' Ogjuk, a constellation marking the winter solstice, or paired the Big Dipper with China's Northern Dipper, whose stars guided imperial astrologers. This isn't about replacing one system with another. It's about expanding our cosmic vocabulary, recognizing that every culture's star lore offers unique insights into the universe's grand puzzle. Now consider how this shift mirrors broader changes in science education, where indigenous knowledge is finally being welcomed not as folklore, but as complementary wisdom. From Polynesian wave navigation refining oceanography to Aboriginal fire management reshaping ecology, the pattern is clear. When we widen the lens, everyone sees further. The stars, after all, belong to no single culture. They're a shared inheritance, waiting for every civilization's stories to take their place in the sky. The next frontier, bringing these celestial narratives into classrooms and observatories, not as curiosities, but as equal partners in humanity's quest to understand the cosmos. Because the universe doesn't just speak Greek, it whispers in every language, sings in every story, and reveals its secrets to those who listen with open minds. At the University of Hawaii's Olani program, The classroom has no walls, just an open ocean stretching to the horizon and a sky dense with ancestral wisdom. Here, astrophysics majors paddle traditional Polynesian canoes by day, memorizing the subtle swells that reveal distant islands, while by night they peer through high-powered telescopes, tracking the same stars their ancestors used to cross thousands of miles of open water. The star compass they learn isn't just a tool, it's a living bridge between epochs, where the Hawaiian names for celestial bodies, Hokulea for Arcturus, Hikyonalia for Spica, carry navigational data refined over centuries. This fusion isn't symbolic, it's rigorous science. When students correlate satellite images of galactic nebulae with chants describing the breath of Cain, the Hawaiian creator god's cosmic exhalations, they're not just studying astronomy, they're reclaiming it. Similar programs are blossoming worldwide. In New Zealand, the Maori Astronomy Initiative Rangiatia trains students to map dark matter distributions using both supercomputer simulations and the Matariki star cluster's helical rising, a celestial event that's guided Polynesian agriculture for millennia. Meanwhile, Canada's University of Alberta partners with Cree elders to document Thunderbird constellations, stellar patterns linked to atmospheric phenomena modern meteorology is only now quantifying. These initiatives share a radical premise that Indigenous knowledge isn't folklore to be archived, but a complementary framework that can refine and sometimes challenge mainstream science. The ripple effects are profound. When MIT physicists analyzed Polynesian star paths using fluid dynamics algorithms, they discovered wave piloting techniques that could revolutionize autonomous drone navigation. Navajo star sand paintings, once dismissed as ritual art, are now studied at Caltech for their fractal geometry, which mirrors models of quantum foam. Even the humble boomerang, redesigned using Aboriginal aerodynamic principles, has inspired more efficient helicopter blades. This isn't cultural appropriation, it's intellectual reciprocity, where ancient and modern insights amplify each other. Yet the movement faces skeptics. Some academics argue blending worldviews risks diluting scientific rigor, while others fret about tourist science, superficial nods to diversity without deep engagement. The solution, as Aulani's founders stress, lies in equal footing. Western astrophysics isn't the default to which indigenous knowledge must conform, nor is ancestral wisdom a mystic alternative to peer review. True integration means letting Dogon Sirius lore prompt new telescope surveys, or using Inuit lunar calendars to refine climate models. The stakes transcend academia. When Chile's Atacama Desert, home to cutting-edge observatories, became a flashpoint between astronomers and indigenous land rights activists, compromise came via dialogue. The resulting collaboration lets telescopes scan for exoplanets, while local communities monitor light pollution's impact on traditions like reading the Milky Way's brightness to predict llama births. Such partnerships prove science thrives not by erasing perspectives, but by weaving them into a richer tapestry. But as we celebrate this convergence, caution is vital. The line between reverence and romanticization is perilously thin. Attention will navigate next, where well-meaning admiration can sometimes obscure the true depth and complexity of ancient cosmologies. It's tempting to gaze at the precision of ancient star maps or the uncanny foresight of oral traditions and leap to extraordinary conclusions that advanced extraterrestrials must have intervened, or that a forgotten super-civilization once walked the Earth. But this impulse, however thrilling, does a disservice to the very cultures we seek to celebrate. The Dogon's intricate knowledge of Sirius, for example, doesn't require alien visitors to explain it. Anthropologists like Walter Van Beek found that while the Dogon possessed detailed Sirius lore, the specifics often vary between villages, suggesting a living, evolving tradition rather than a static revelation from the stars. Their understanding might instead stem from a rich, undocumented African astronomical network, where knowledge was traded along Saharan caravan routes or preserved through griot storytelling long before European telescopes arrived. The same logic applies to feats like the Antikythera mechanism or Mayan eclipse tables. These weren't gifts from the gods, they were triumphs of human perseverance. Consider the Polynesian navigators who memorized star paths across generations, or the Babylonian scribes who logged Venus cycles for centuries. Their achievements weren't magic, they were the result of meticulous observation, trial and error, and cultural systems designed to preserve hard-won insights. When we default to ancient aliens narratives, we risk erasing the ingenuity of these societies, reducing their brilliance to something passive rather than earned. That's not to dismiss the genuine mysteries. How did the Dogon describe Sirius B's density without telescopes? Why do Vedic texts echo modern quantum theory? These questions deserve investigation, but the answers likely lie in overlooked human innovation rather than interstellar intervention. For instance, the Dogon might have inferred Sirius B's existence through its gravitational effects on the primary star, a technique similar to how astronomers today detect exoplanets. Similarly, Vedic seers' insights into atomic structure could reflect deep meditative practices that sharpened their intuitive grasp of nature's patterns. The key is balancing awe with accountability. We can marvel at the Great Pyramid's celestial alignments while acknowledging the Egyptians' mastery of geometry and long-term planning. We can ponder the Nazca Line's precision without imagining ancient runways for alien craft instead, recognizing how simple tools and communal effort could achieve staggering accuracy. This approach doesn't diminish the past, it honors it, treating ancient cultures as active participants in discovery rather than passive recipients of cosmic handouts. So where does this leave us? The next frontier in rewriting cosmic history isn't about chasing extraterrestrial ghosts, it's about deepening collaboration between astronomers, archaeologists, and indigenous knowledge keepers. Imagine combining LiDAR scans of Angkor Wat with Khmer star charts, or using AI to cross-reference Babylonian clay tablets with modern supernova remnants. The real mystery isn't whether ancient people knew more than we thought, but how much more we might learn if we listened to their legacy with both open minds and critical eyes. The cosmos they mapped wasn't a puzzle to be solved by outsiders, it was home, studied with an intimacy we're only beginning to reclaim. The James Webb Space Telescope isn't just peering into the depths of the universe, it's also glancing backward in time, offering us a chance to test claims etched into ancient star charts and temple walls. When it trains its infrared eye on Sirius, astronomers will scrutinize the binary system's movements with unprecedented precision, potentially validating or challenging the Dogon's centuries-old descriptions of its companion star's orbit. Similarly, Webb's observations of the Pleiades could reveal subtle gravitational interactions that Polynesian navigators might have referenced in their chants about the cluster's binding energy. This isn't just about validating the past, it's about unlocking forgotten insights. Ancient observers recorded stellar behavior over generations, data that could help modern scientists spot long-term cosmic trends invisible in our brief observational window. Meanwhile, artificial intelligence is breathing new life into crumbling manuscripts. At Oxford's Bodleian Library, neural networks are restoring charred Babylonian clay tablets, revealing previously unreadable eclipse records. One recovered fragment from 600 BCE details a solar eclipse's duration to within minutes, data now helping astrophysicists refine models of Earth's ancient rotation rate. In India, machine learning is decoding palm leaf manuscripts where Vedic scholars described variable stars like Mira centuries before European astronomers. These AI tools aren't merely translators, they're time machines reconstructing knowledge streams interrupted by war, colonization, or the slow decay of parchment. The democratization of cosmic archaeology is equally groundbreaking. Platforms like Zooniverse's Ancient Skies project invite anyone with internet access to compare medieval star charts with digital sky surveys, flagging anomalies that might represent supernova or comets. In 2023, a retired teacher in Portugal spotted a discrepancy in a 15th century Persian manuscript's Jupiter observations, leading to the rediscovery of a lost asteroid impact event. This collaborative model mirrors the very traditions it studies. Just as Mayan priests shared eclipse tables across city-states, modern citizen scientists are weaving a global tapestry of celestial knowledge. What emerges is a new kind of cosmic dialogue, where a 13th century astrolabe inscription might calibrate a satellite's orbit, or an Inuit elder's moon phase chant could help date a prehistoric volcanic eruption. The future of cosmic archaeology isn't about proving who was right, but about recognizing that every culture's star stories are chapters in a single, sprawling epic, one we're only beginning to read. Now we turn to voices often left out of the astronomy textbooks, modern stargazers bridging ancient and contemporary knowledge. From Navajo engineers integrating traditional star lore into telescope designs to Ghanaian coders building apps that overlay ascent constellations onto planetarium software, these innovators aren't just preserving the past, they're redefining how we map the heavens. When a Maori astrophysicist names a newly discovered galaxy after the ancestor Papatuanuku, or a Cherokee robotics student programs drones to follow ancestral star paths, they're doing more than blending traditions. They're proving that the cosmos speaks in as many languages as there are cultures to listen. This inclusivity is reshaping education too. Planetariums from Tokyo to Toronto now project multiple constellation systems simultaneously, letting visitors toggle between Greek and Aboriginal sky maps with the swipe of a hand. In classrooms from Norway to New Mexico, kids learn that Orion's belt is also the Maya's three hearthstones, or the Lakota's spine of the bison. The lesson goes beyond astronomy. It's a masterclass in perspective, teaching that truth isn't singular and that the universe reveals itself differently depending on where and how you look. The most exciting discoveries may lie ahead as these cross-cultural conversations spark new questions. Could Yoruba star names hold clues to unmapped dark matter clouds? Might Tibetan monastery paintings of rainbow spheres describe atmospheric optics we've yet to document? With each collaboration, the boundary between ancient and modern blurs further, revealing a cosmos far richer, stranger, and more interconnected than we ever imagined. The stars haven't changed, but our ability to hear their stories in every human tongue has only just begun. Some of the most breathtaking discoveries in cosmic history don't come from high-powered telescopes or academic journals. They emerge from the curiosity of everyday stargazers. Take Sarah, a high school teacher in New Mexico, who noticed something peculiar while visiting Chaco Canyon. As sunlight streamed through a petroglyph spiral on the summer solstice, she realized the ancient Puebloans had carved a celestial calendar into the rock face. Using nothing but a smartphone app and patient observation, she documented how different spirals aligned with equinoxes and lunar standstills, adding new layers to our understanding of ancestral astronomy. Her story isn't unique. Across the globe, amateur astronomers and history buffs are becoming citizen scientists, uncovering hidden connections between ancient sky lore and modern cosmic truths. Then there's Rajesh, a software engineer in Bangalore who grew up listening to his grandmother's stories about the nakshatras, the lunar mansions of Vedic astrology. What started as nostalgia turned into a passion project when he coded a program comparing these ancient star divisions with modern exoplanet discoveries. To his astonishment, several nakshatras aligned with regions now known to host habitable zone planets. His findings, shared in an online forum, caught the attention of astrophysicists studying galactic habitable zones. These stories weren't just myths, Rajesh reflects. They were maps passed down through generations, waiting for us to read them with new eyes. The democratization of technology has turned backyard observers into cosmic detectives. In Norway, retired fisherman Lars combined drone photography with medieval Norse sagas to pinpoint a previously overlooked Viking navigation site. The sagas spoke of a sunstone, used to locate the sun on cloudy days, a legend long dismissed until Lars noticed peculiar crystal deposits at the site. His discovery led researchers to confirm the existence of calcite sun compasses, tools that predate magnetic compasses by centuries. Similarly, a group of Australian high school students cross-referenced Aboriginal songlines with satellite data, identifying a meteor impact crater described in oral traditions as the place where the fire star fell. These stories reveal a profound truth. Cosmic knowledge thrives when it escapes the ivory tower. When Maria, a librarian in Guatemala, noticed her town's annual festival coincided with the zenith passage of the sun, an event sacred to the Maya, she organized a community project to restore an overgrown observatory mound. Using colonial-era manuscripts and local elders' memories, they rediscovered alignment stones that marked not just solstices, but Venus's 8-year cycle. The sky was our ancestors' library, says Maria. We're just learning to read it again. What unites these modern-day skywatchers isn't specialized training, but a willingness to listen to both the cosmos and the whispers of those who studied it long before us. Whether it's a teenager spotting Jupiter's moons with binoculars while reciting Polynesian navigation chants, or a historian decoding eclipse records hidden in Egyptian temple invoices, each contribution stitches another thread into humanity's grand celestial tapestry. The most exciting realization: you don't need a PhD to join this adventure. Sometimes all it takes is looking up and remembering to ask, what did they see when they gazed at these same stars? As we near the end of our journey, let's pause to consider how these fragments of wisdom from Dogon oral traditions to Greek astrolabes aren't just artifacts of the past. They're invitations to reimagine our relationship with the universe, blending the precision of modern science with the poetry of ancestral sky stories. The cosmos doesn't belong to any one culture or era. It's a shared inheritance, waiting for each generation to uncover its secrets anew. We've traced the stars through time, from the precise alignments of Mayan temples to the quantum whispers of Vedic texts, and found something remarkable. This journey wasn't about crowning one tradition over another, but about discovering how each culture's unique lens reveals facets of the cosmos we might otherwise miss. Like astronomers piecing together a mosaic from scattered fragments of light, we're assembling a deeper understanding of the universe by honoring every voice in humanity's grand celestial chorus. Take something as seemingly simple as a constellation. To the Greeks, Orion was a hunter frozen in the stars, but to the Maori, those same points of light formed the prow of Tamareti's celestial canoe, sailing the Milky Way. Both stories, one rooted in mythic drama, the other in navigational wisdom, capture truths about human imagination and our relationship with the heavens. When modern telescopes peer into Orion's nebulas, they don't erase these narratives. They add new layers, showing stellar nurseries where stars are born, echoing creation myths from Egypt to the Dreamtime. The real magic lies in the dialogue between eras. Polynesian navigators who memorized star paths across generations would marvel at our GPS satellites, not as replacements for their knowledge, but as kindred tools for wayfinding. Similarly, the builders of Stonehenge who tracked lunar cycles with stone computers might nod in recognition at our atomic clocks, both striving to tame time's flow. This continuity reminds us that science isn't a linear march from ignorance to enlightenment, but a spiral where ancient insights, once dismissed, often circle back to inform cutting-edge discovery. So what's next, as the James Webb Telescope unveils galaxies older than Earth itself, and AI deciphers long-lost star catalogs from charred clay tablets, we stand at a thrilling crossroads. The challenge isn't just technological, it's cultural. Can we create a future where an astrophysicist cites Navajo starwalkers as readily as Newton, or where a child learns the Dogon Sirius law alongside Kepler's laws? The universe, after all, doesn't care which language we use to describe it, only that we keep listening, learning, and sharing what we find. As this chapter closes, consider this. Every time you glance at the night sky, you're part of an unbroken chain of curiosity stretching back to the first human who looked up and wondered. Whether your tool is a smartphone app or a hand-carved astrolabe, the questions remain timeless. What's out there? How does it all connect? And what will future stargazers uncover in the stories we leave behind? The cosmos is vast, but our collective awe makes it feel like home. Now it's your turn. What celestial mystery, ancient or modern, sparks your imagination? Drop your thoughts below, and let's keep this cosmic conversation glowing like the stars